Okay. Although this case study isn't actually affiliated to smartPCN, what the outcome of this project actually did was to allow Alan Webb to start reviewing our own obsolescence management and IKM practices, in the fact that we do need to look at tools like smartPCN sort of going forward. So Alan Webb's got a strong pedigree in asset management sustainment principles. We operate throughout the aerospace and defence sector, and it was because of these principles and experience that led to GSK seeking their support in establishing configuration, availability and maintainability of their production plant for the particular product that they were manufacturing, which I won't go into, but I'm sure you can work out what it was. Okay, briefed it on Alan Webb. So we've been going for 60 years. We're still privately owned. We've got about 240 staff now with about a £17 million turnover. So you'll see from the wheel there that we do a lot of support engineering, and obsolescence management is one of the key disciplines that we do for that. And we're also a trainer for the IOM as well. So the customer requirement here, they were concerned that the production plants were being affected by obsolescence across their facilities. They didn't know what the configuration of the production plants were, and this was quite a significant disruption to delivery of important pharmaceuticals for them because of what was going on at the time. This was during the 2020s. And if they had a break in the production lines, then this would be costly in terms of revenue and obviously getting that particular product out to the marketplace. Right, so looking at what the customer's needs were, GSK were looking for a complete solution to manage obsolescence and understanding what the risk was associated with their aging plant and inventory management. Certainly looking at what inventory they held, and was some of that going obsolete as well. So we were looking at monitoring and putting processes around inventory. Alan Webb's expertise in managing OM across in the defence marketplace, looking at support to ships and things, we were able to use a lot of the processes and knowledge and bring that forward, and using our Alan Webb's Diamond OM tool and environment was seen as an effective way to actually record all this information and record the change and the configuration of the various plants. So our approach then to supporting GSK was that each production line was of a different configuration with a limited knowledge on the commonality of parts. Our history of information knowledge management was seen as a key factor for multiple asset levels and quality of information. So we were able to go onto site and actually do an eyeball inspection against each of the production lines, legacy production lines, and then produce a digital BOM for each production line. And some of that information was drawn from not only doing a visual inspection, but actually drawn from tech docs and technical data packs as well. So we scraped those and got this sort of digital legacy twin, if you like, of the various production lines. So what we've got here is a view of looking at a given asset, and these are all the things that we get involved with in terms of gathering the data, looking at the people, the process, looking at cost avoidance, and looking at all the things that would constitute the obsolescence environment in some shape or form. And these principles that we've got here, they've been taken from our defence work that we do. Right, so technical challenges we found when we were actually undertaking this project. As I've already said, the production lines were of different designs and configurations, and we also found that some of the equipments and subsystems of the machinery were at different stages of their life cycle, which meant some items were sort of still available and others weren't, which then drew conclusions to what strategy do you implement, at what point do you sack that particular item off to buy a new system or what. So there was lots of conversations to be had, all of which is driven by money, of course. So the modifications and changes made to the machinery were not consistent. So again, that was a configuration management issue where we found that System A on 2 production lines was of a different configuration but did the same job. So again, recording all that information to reduce the amount of parts that they had or had to keep an inventory was also paramount. And where we had issues and risks to be resolved, the mitigations, the paramount rule there was the production lines must be kept operational. So we could not interfere with those operations at all because they were just running 24/7 and they were flat out. Some of the other challenges that we also encountered was the lack of configuration control and the knowledge the staff had. Because a lot of the staff had just been drafted in. So again, the engineering backbone of the production lines was lacking. And so again, as I said earlier, having to undertake a physical check and validation for each production line to get a sound inventory baseline was essential. Okay. So once this baseline of plant bills and materials had been established, they were loaded into Alan Webb's Diamond OM asset management environment. And it was from here that we could then go out and do life cycle and risk analysis at the system, subsystem and item level. And then, give a clear give a clear and visual asset availability picture to the client, whether you're driving down from the production line down to item or from item going the other way, and also looking at used on and what that resolution meant, because you might have a different resolution strategy for one asset compared to another. So this is the sort of basic process that we follow in terms of status of monitoring, risk analysis and case management, etc. The tool that we were using does sit on the RLI, that's a restricted network, that's for mod projects. However, we use the same encryption and 2 authentication protocols as we do for the RLI for non-mod customers. So that was the way that we were enabled to ensure that there was no transfer of information and only the client would look at their bills of materials. Okay, so the outcome from everything that we did, GSK experienced significant business benefits on return on investment from implementing the OM strategy and service that we employed. It gave GSK the confidence that the production lines were protected, not only now for that particular duration, but actually for future years. They then began to do the analysis of when they would need to plan upgrades, and it meant that they wouldn't have to do that immediately, which obviously comes with quite a high return in terms of cost. And when considering opposite asset management, we demonstrated that the defence benchmark principles and practices we used could be rolled out across multiple sectors and not just defence. So that was a good plus for us. Right, so looking at the sources of data change, PDN, PCNs, yes, we've been talking about that all day, but the other elements that we were using was data mining. This is where we go out direct to manufacturers to collect information, certainly when it comes to software and you're looking at life cycle management and then extended security periods, etc. Product roadmaps as well, if we can get those. And we're also looking at prediction tools. Alan Webb's developing its own AI and ML algorithms to look at trends on various families of technology types. Okay, so we were able to provide GSK with the necessary dashboards that they wanted, and this was pseudo implementing into product lifecycle tools and things like that. That's something that Diamond OM were going through those particular controls at the moment. We are doing some work with the MOD on that, but one of the biggest problems we seem to have in the defence world is firewalls and protocols. So we're wondering how we can get around that. There's a Cyber Essentials that we do meet as a standard, but yeah, that's causing us a bit of problem at the moment. And then finally, my last slide. As I said earlier, what this has done, the work that we have looked at with GSK, a lot of it was mechanical, software and electrical items, all of which has pointed ADOL to undertaking a study to see how the Diamond tool that we use, which manages at the asset level, how we interface to tools like smartPCN environment to further benefit our customers. So that's me, thank you. Any questions?
Thank you, Tim. So this was very short, but there is already a question here from Phil. So in particular, so I don't know whether you can see that in the chat already. Yeah.
Yes. No, not yet, Phil, because I say we haven't adopted smartPCN. So what we've just realised is that the work that we've done does warrant using a tool like smartPCN. So I'll say traditionally is probably the wrong term, but we've stayed away from smartPCN. But actually, with the way that the marketplace is going, we feel that it's something that we need to be considering and be involved with. So I hope that answers your question.
So other questions? Okay, from Chris Green.
It would have added to, it would have been provided probably more information. And it probably would have reduced the amount of time that we spend data mining and trying to get to credible sources of data. So in hindsight, I'll probably say yes, it would have done.
Yeah, maybe I think, Tim, what you did is also what my former company does for a large company in Germany with thousands of manufacturing machines and so on. So the big problem you have with production machines is that, first of all, there is no really procedure as we have in the electronic industry to issue those PCNs. The next thing that you have is you buy a machine from a machinery manufacturer. But a machinery manufacturer buys now, by today, a lot of components like relays and switches and things like this. And so the ones that get the PCNs is not the final customer, is the one that produces the machine. And in case they do not have an obsolescence management, as we know from most of electronic industry and defense industry and so on, you exactly have this problem. So you cannot use a smartPCN because, as it has been raised in a question before, if you do not have the bill of material, then it's very difficult. And I believe most of your work had been to find out what is in those machines, right?
Yes, that's right. Yeah. So to produce that bill of materials.
And I know this other project I was talking about, they have now collected more than 150,000 spare parts. They didn't have them before. And
a lot of inventory, a lot of money.
Yeah, and this is really one of the big challenges, that we get smartPCN as a standard also in the machinery industry, because there's a lot of I don't tell anybody that this part will not be anymore available. That's the first thing. And the other way is that most of the machinery builders, they have no idea that this part is no more available. They find it out when the customer orders a spare part. So we have to bring those methods of obsolescence management in those industries as well.
Indeed.